Looks like it's, fingers crossed, it's all going to work today. Hello, and welcome to Practicalli Clojure with me, John Stevenson. Thank you very much for joining me. And today we're going to continue building on the web server that we started in the previous video we did last week, where we built a very simple web server, just using Clojure and using Clojure command line tools and Clojure deps. And this time we're going to extend that and add some routes and serve up some JSON and make it into more of an API that's served rather than just a simple website. Okay, switch over to and feel free to ask any questions in the website. And if you go to Practicalli, practical.li or practicalli.github.io, then there's all kind of the information about the books I'm writing and all the videos. And if there's anything you'd like to discuss about what we're doing in the videos, then feel free to reach out to me on the Practicalli channel on the Clojure in Slack, and you can sign up to a free account if you don't already have one. It's a very friendly community, so you can ask me in Practicalli, which is pretty low traffic, or you can go and use some of the other channels where there's a lot of other people there to also help you out on lots of different topics as well. And if you find these videos useful, then please consider sponsoring me or supporting me by subscribing to my YouTube channel. There's over 50 videos on there now, all freely available. I'm not trying to sell you anything on Black Friday. All my free videos are still free on Black Friday. And if you wanted to sponsor me, you can add money to the charity ride I've just recently completed about riding across Britain. You can send me money directly via PayPal, and you can sponsor me on GitHub as well if you want to pay in US dollars. And there's lots of resources and stuff I'm going to add there to that. I'm going to add some other podcasts and so on that I think is quite useful. I'll add that to this website too as well. Okay, so the work that we're going to do today is all written up in this blog post I've just published. Pretty much, well, last night or this morning, depending on what time you consider morning starts. And so it's this Clojure Webapps routing with APIs, and so it's building on from the previous article that we used last week. And we're going to kind of mainly focus on something called compojure and this idea of def routes, and show you how to be able to handle multiple requests from different addresses on your particular server. And we'll also use a library to help us generate JSON as well. Okay, so let's have a look at compojure. So I've got this little graphic here which hopefully helps kind of visualize what's going on. So if you imagine before this adapter, there's your browser, and if you're browsing, if you're viewing web pages, then you'll make HTTP requests. So HTTP is the protocol that you send over the internet to ask for web pages, websites, and other resources that are on the web. And all those requests get received by the web server. In this case, we're using Jetty, which is a Java application server that's been around for a long time. We're using an embedded version of Jetty. And so that's listening to all of the requests from everybody in the world if this web server is online. And this is referred to as an adapter because what it's doing is it's taking these requests that follow the HTTP specification, and it's basically turning those into a nice Clojure data structure, specifically a Clojure hash map. So just a set of key and value pairs, and that makes all the requests really, really simple to deal with. because all you're doing is just reading and manipulating and transforming a clojure map, which is pretty simple to do. And so those requests can come in, and they need to go somewhere to be able to send back a response map. So, and then the response map will be converted by the adapter back into a HTTP response and send that back to your browser. So the adapter kind of takes care of all that. So that's what we did with HTTP kits, and you can also use Ring as well. They're all following this Ring standard that's kind of evolved from the development of the Ring library. And as these requests come in, you can pass them through middleware. You can do things to transform them before you decide how to respond to that, or you can also post-process any responses. So if you want to put all your responses into a particular template, web page template, or if you wanted to check certain things before you sent them out, you're basically, you can use middleware for that as well. And middleware is simply just a function that is going to take a response and returns the response. So it's just taking a map, Clojure hash map, and generating a Clojure hash map in the format that we discussed last week as well. So basically, just need to make sure that it's got a status, a header, and a body. And so the thing we're going to look at mainly today is this idea of roots. And so roots is this thing we're going to define with a function called defroots. Well, it's actually a macro from the Compojure library. And this is a bit like a big if statement, a big con statement. I guess that's more accurate to say it's a big conditional statement. And depending on what the address is and what the HTTP method is, excuse me. So depending on what the root is, and a root is made up of a HTTP method, we'll have a look at that in a second, and a specific web address or resource address, and that could be something simple like hello HTML. So if our website is practicalli.li, then it'll be /hello.html. That's the root for that particular website, and there can obviously be multiple different pages that are roots, but you could also return JSON as well. You could return things that aren't pages but are still perfectly legal things to do over the internet. And the HTTP method switching, that is this idea of get or a post. So when you go and browse a website, each time you ask for a page, you're running a get HTTP method. That's what your browser is doing for you, and that's what your browser sends a request to the web server as a get or a post. So if you're filling in a form, then you'll be doing a post because you're posting information to the web server, whereas get is just doing a simple read, and this is more like a write. And there's other methods as well, but get and post are the main ones that people use. And this route is sending things to what we call a handler that basically do something to take the request in and return a response. So this basically is a handler. This handler is handling how we deal with this request and determining what we actually send back in return as a response, and then that just goes all the way back through to the adapter and back to the client. So that's the theory about how Compojure actually works. Is there any questions on that? Ooh, got 5 people listening today. Oh, excellent! Thank you very much for joining me. Feel free to ask any questions in the chat as we go along, and if there's something that's not clear, please let me know. And we'll also look at some of the convenience functions that Compojure has. It just makes it a little bit easier for us to write handlers and and produce some nice output from there as well. And if you go to the Practicalli Clojure web apps, there's this is all kind of based on Leiningen, which is I've got like building a website with Leiningen and LineRing, which is kind of there's been the standard approach to using Clojure projects for a while. So what we're doing in these broadcasts is slightly newer because we're using clojure-cli, but essentially everything else is the same. I'm using Ring here rather than HTTP-kit, but again, it's using the same standards, so we're doing the same thing. So you might find this quite interesting. We connect up to a database and so on, so we'll be doing some of these things as well in our broadcasts. Okay, no questions. Cool. Okay. So we have our server from last time, and I think I put a link in there. Did I put a link in there? I'm not sure if I did. So if you haven't got the... Ooh, that's not good. Oh, that's a nice error message there. Oops, did I break that? Oh, okay, Eden. Oh, yes, MD. Let's go to Practicalli. Boom, boom, boom. Oh, I think I meant to publish that yet. So if you have a look at this Clojure web server from scratch, it's in this Practicalli simple server API server. Boom, boom, boom. So if we go to GitHub, I should be able to paste that in. And that's not what I'm looking for. Where did I put it? How do I call it? Simple API? Let's see. Oh yeah, I haven't pushed that other one, have I yet? So so if you go into GitHub Practicalli simple API, then you can get the code from last time if you don't have it, and it's pretty straightforward. Deps.edn file, we just added Clojure and HTTP kit, and everything else is pretty standard stuff. We haven't added. We just use Clojure CLJ new as a plugin to create this, and then just added HTTP kit. So we're going to extend that. And the source, the code was pretty simple. We basically just had required HTTP kit. We defined a handler to be able to send back some content, and we had a start and stop server, and we basically just ran our web server just by running this main and optionally specifying a port as well, and just running the server, and then we can respond to we respond to requests, but each time we'll just send we're sending everything to the handler, so whatever we request from the web server, it's only ever going to return hello Clojure server world, which is not particularly useful. Okay, let's go and add Compojure to our project. So we can always go and look at which version of Compojure is the latest version when we're building an application. There are some tools that you can run on your project to tell you whether your existing libraries are up to date as well, if there's newer versions. There we go. So here on Clojures, I did a search for Compojure, and it came up with this page, and it's giving me the secret bit of code snippets to put into my projects. So if I'm running a line boot project, just do a simple vector with this, but we're doing a clojure-cli deps.edn project, so we're going to use this Compojure version here. So basically specifying we want to include the Compojure library, and it's going to be a Maven dependency. So it's a Maven dependency because we're pulling it from a Maven style repository. So it'll either be from Maven Central or from Clojure itself, depending where it's published. If it's just published on, if it's not published on Maven Central, then we'll get it from Clojure. So if I switch to my project, which we were working on last time. So this is the simple API server. This is the main code. So this is the in the source Practicalli simple API server. That is there's the file we're looking at, and we added a couple of things. We had this HTTP response, which is just a map lookup for that as well. I actually extended this to a different namespace, which I didn't put in here. Oops. Let's go to 6. So I actually created this. I'll put this into the GitHub repo as well. But yeah, basically copied all the status codes in there as well, so it makes it a lot easier to just go and find codes. And because it's a map, you can just do a quick lookup. You can do a quick lookup either way. I'll probably include a def in here as like the codes in reverse, so you can kind of take a code number and then it'll tell you what the name of that code is as well. It's just a handy little helper namespace. So yeah, and because it's quite a long bit of code, I've just put it in its own particular namespace in here. So I'll do that with I'll put this into the project on GitHub at the end of the broadcast. So we were going to add compojure. So first of all, we need to add that to our deps.edn file. So if we go back up a little bit, so go back up to the main roots of our project, and then we got our deps.edn file there. And you can see we've got there we go. We've got our dependencies already. So we've got Clojure's library and we've got HTTP kit. And so we just paste in compojure there, and then that will, whenever we run our REPL or run our project, it will, if we don't have compojure at this version already available, it'll download it from Maven Central or Clojure's. And now we just need to go in and add it to the namespace where we want to use the functions. Switch back to there. So we need to we want to be able to use those functions from Compojure, and there's a couple of different namespaces we want to work with. It's quite well organized, but there's quite a few Compojure namespaces for different things to. But looking at the Compojure, we're going to look at the Compojure API. So we Clojure, Compojure. Oops. So if you go look at the API docs, you can see all the different namespaces you've got and what functions you've got in each one of these. So we're going to use core, and which has got the get and the post, and also the def roots, I think. Yeah, def roots. And we're also using, we're going to include response at some point as well. And root. Root has this no found or not found thing, and also resources is a useful one for serving up static content as well. So if you've got HTML content, CSS pages, and so on, you can put them into a public. Excuse me, I've got a bit of a cough this morning. Yeah, so you can use resources to put things into a resources public folder, and it will like serve up HTML and CSS and JavaScript from there. So you can use things that you're not part of your code fairly easily. All the static resources, including images and so on as well. But we're going to oops. There we go. Namespace index. Okay, so we're going to add some of these in. So we're going to add Compojure core and Compojure roots into our code. Let's see. Boom, 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 boop. There we go. So let's switch back to our editor. Oops. Boom. And so we're going to keep the HTTP kit, and we'll just put it in after that. So with require, we can use, we don't need to put require in front of each of these things. It will just take them all in as additional ones, additional configuration it needs to pull in each time. So this is just like having require on each line, but it just saves a bit of typing, and it actually keeps it a little bit more readable, because you know you're going to require all these, and you just want to actually see what you're actually requiring and how you're actually requiring them. You could be a bit more pedantic and line them all up as well if you wanted to, but there we go. Boom. Depends how neat you like them and how obsessive you are. And so it's so what we're doing here is we're including Compojure core, and rather than just give them an alias, we're going to we could give them an alias of Compojure, but coming up with an alias name that's meaningful is quite tricky. There's going to be, I don't want to refer everything in this namespace, so I'm just referring specific functions in here. So I can use this function as if it was written inside this namespace using the refer keyword here. So when I want to do something, so rather than so in the handler I can now include this def roots thing, and it's appearing in my auto completion list as well. So I can define it. I don't need to specify any aliases. I can just use it as if it was a function included in this namespace already. The same thing with get and post, and in Compojure root I'm doing the same thing with not found as well, which we'll use a little bit later. You can see that some of these things are underlined by my linter, that I haven't actually used them yet. Oh, interesting. And yeah, so as I actually use these things in the use these functions in the body of my code, then my linter will just remove that underscore. So it's a good way to see whether you're actually using these functions that you're requiring or not. And if you're not using them, then obviously you can remove them from the require and make your code a bit simpler to understand. Okay, so we've got Compojure added. Let's go back and see what we got. Oh, and then yes, and then we can define some roots. So this is a new function. We could think of it as a function, except we're using a slightly different language. So def roots isn't part of the Clojure language. This is a macro. So this allows the allows anybody, but specifically allows the developers of libraries for Clojure to extend the language of Clojure. So instead of def and defen, we have def roots, which does something more specific than def, but we're still calling it essentially as a function. So let's include that in our code. So we're going to put that before the system stuff that we've defined, but before, yeah. So but after any handlers we're going to do. So we're going to define some handlers here to respond to requests. I guess. And then this is going to be our def routes. Let's paste this in. So this is where we're going to manage our requests. Oops, we can get rid of that. There we go. So our def routes, it just takes a name. We're going to call this web app. Because this is essentially where we start organizing the logic of our application. So here we start making some decisions about what it's actually doing. So we just refer to this as web app. Some people call this app as well. And essentially we've got like three routes. So each of these things is a route. We've got 3 routes, and each route is composed of so a HTTP request. So the request method, so whether it's get, posts, or any of the other HTTP methods, and then it's an address, and this address is just the root of the web server. So if you went to google.com, this would be the request address that you're using, because you don't have any specific page in there. It's probably going to pick up like the index HTML or whatever that web server is going to serve up by default if you don't give it a specific page or a specific address. And we're going to pass the request on to whatever function we are going to use to deal with the request. So in the previous example, we just simply returned a response map with its status headers and body, and we just return some HTML. That's quite simple. So here what we're doing is just this would be our function. So this hello world, hello HTML, hello world is just our function that we're going to use or going to write that's going to handle this. So rather than include like specific a map inside here, inside the def routes, which would get quite messy. If everything was like a def route in here, then so if everything was a map in here, it'd make our def routes quite involved. So we basically pull out how we respond to this route by defining a function, and that function in Ring terms is a handler. No questions yet? Nope. Cool. And so, and the same thing for the next one. So yeah, we're just specifying a different URL. So if we go to Practicalli / hello-response, then it's going to call a different function, a different handler, and send back a result then. And if none of the things above match, we've got this not found function that we're calling instead. So instead of doing like instead of matching on get, here we're just saying that yeah, if this is like again, if you go and think about this as a con statement, these are kind of possible options you can match on. And if we don't match on any of these options, then we'll just use, by default, we'll just go and use the not found, the last thing. So this is rather than sort of like relying on the browser to have a not found. So we go to, if we go to our web page and we go and open a localhost 800, which isn't, we haven't actually got a server running, then your browser will probably have some kind of amusing web page template that it uses, and you can, which is okay, but you don't. It's not part of your website, so you can actually use this not found and send back your own kind of message. You could also wrap this into a template, either with a function call here, or putting it back as some middleware that works on the response and puts that back into a template as well. But this not found essentially just returns a page for you that is your own page rather than the browser's 404 response. Okay. So we do need to add these functions here. We haven't actually got hello HTML and hello world yet. So let's go back to our browser. Boom. So here's our hello world. Boom. Okay. And so as we're as hopefully we've discussed before, Clojure, when we run Clojure, it reads it from top to bottom. So if we're going to call a function from another function, then we need to define that function above where that function is being called. So now you can see that the hello world, the line on that hello world function call has now disappeared because we've defined this hello world function that we can actually call now and defined it in the right place. So we still need to do something for hello HTML. In fact, we can just change handler to hello HTML. I think that will do for now. Hello HTML, there we go. And now we've created it, our linter's happy that we've got our code in there. So it's a nice quick way to check that your code is working or is going to work. And here we're using response, which is another Compojure helper function, but we haven't actually included that yet. So that's why it's saying it's not going to be able to call it. It's unresolved. It doesn't know where that function is, so it won't be able to actually call it. Did I put that in the blog? I think I might have missed that out. I did miss that out. Oops. I shall add that in. So if we go to a project I did earlier. Let's go here. Yes. Oh, there we go. Oh, it's a Ring utility response thing. So this is part of Ring. Yeah, there we go. That we can include. So we need to include this in our API. There we go. Oops, no. So if we add this after Compojure, before that, let's add it in the right place. So it's just another require that we need. And what's that part of the 6? I'm just going to check if that's part, if I need to add anything for the dependencies, or I think it might just be covered in Ring. Oops, let's look. Yeah, it's all part of, I think it's something that Compojure includes, so we don't need to include it specifically in the dependencies. So now if we've saved that, then yes, our response is now happy. One thing I thought about, so I'm using, using rec for the argument for these handler functions. But I thought request was more meaningful, but then if we're not actually using the request name anywhere, so we're not actually using it here, so my linter is saying, ooh, it's not used, it's telling me it's unbound, it's not used this binding anywhere, this name anywhere, which is true. I haven't actually used the Ring response, so it's actually telling me yeah, it's unused. So I could actually, I do need to specify an argument that takes some kind of response map, but there's also a character called the underscore, which you can use to say, okay, this is going to represent a name, but I don't really care what the name is because I'm not actually going to use it. So it's a bit like a placeholder. So it'll take in an argument, but we're not actually going to use it, so we can just throw it away. So we could use the underscore, and it actually kind of demonstrates that we are taking an argument, but we're not actually using it. If we do actually use the request, then we can give it a nice name that we can use. And it just makes the code, I think, more readable if we do, if we have the underscore in there as well. It just shows that we're taking an argument, but we're not actually going to do something with it. So that was quite nice. And so now we've got our roots and we've got our handlers that manage the roots. So we should have a working application now, hopefully, if we haven't broken anything. Let's see. How are we doing? 36. Okay, and yes, there we go. There's also a nice function here, which is, oops, wrong way around. There's a nice function in not that one. Yeah, there's a nice function in ring handler called Handledump. So if we actually wanted to see what the request map looked like in a nicely formatted page, we can also include this ring handler dump in here. So let's include that as well. Sometimes it can get a bit abstract to think of what's actually in the map. But if we include this, we can generate a nice page that just shows us an example of that map. Oops, let's put that in. Boom. And we're not using that, so we go to our def roots and we can include a new root that will just display that page. We can just basically get the page, so we just basically, it's kind of almost like echoing the request back to us, but as a in the clojure format, so we can see exactly what it's actually doing in there as well. Boom. And we need a Handledump page. So yeah, we need a Handledump header to be able to handle this. Let's stick that in there. If I go back to the website, if we go back to Practicalli Clojure Webapps, that's not the right one. Did I close it? I might have closed it. Let's see. Let's go back to Practicalli. So we go back to the book, Clojure Webapps, and is it in here? I think it's in here. About roots. There we go. So we can add. Oh no, not that one. Show request info. There we go. Yeah, so we can do this. We can print this out manually because it's just, again, it's just a map here. So this request info is just going to just do a print string on the request that we're passing in. So that's pretty straightforward, but it's a bit tricky to read. So if we include this Handledump, then we actually get a nice view of the code there as well. So we'll just include this bit of code. Where's it gone? Oh yeah, so we've got that. Oh yeah, we don't need. Oh sorry, we don't need to write a function because Handledump is a function. What are we talking about? Yeah, so we're including this Handledump function from ring Handledump namespace. And yeah, sorry, my brain just switched off for a second. There we go. And so this will print out the particular response. So if we save that, we should be able to just run our run our server now. So I can run it from the I can run it from my editor. I'll do that next, but let's just run this from the command line. And where is my terminal? Where close my terminal? Oops, there we go. Let's open up a term. There we go. So change to the project, project Clojure, and then simple API server. And then we will, so this is the project we're in, and we can have a look at the source code. We'll have a look at the deps file. Just check sure. Yeah, so we've added Compojure in here now, but we can just run it just the same. So we can run it. We can just run it on the command line, which use clojure, and then specify the main, and it's Practicalli, and then it's simple API server. If I remember that right. Yeah, so this is basically going to run Clojure, and it's going to use the function that it finds, the default function, which is usually -main or main, from this Practicalli simple API server. And so if we press enter, it might need to download a few dependencies if it doesn't already have them. Otherwise, hopefully, if I spelled everything right, it will start a server. Something's happening. My fans are going away on my laptop. I do need to get a new laptop. Oh, okay. It's not liking Handledump. Maybe I need to pull that in from a different. Do I need to add that? Or did I spell that wrong? Oh, something's not right there. Oh, it's saying ring Handledump. Have I? Oh no, that's right. Maybe that API has changed. So I'll comment that out for a moment, and then try and run that later. So if we got a broken route, I can just go in and comment that out. And it should just work. It should just ignore that line, or I can or I can just do put a I use the reader macro comment on there as well. So just the #_ will comment out. Will tell the reader just ignore that line completely. And let's see. Oh yes, it doesn't like that, does it? Oh, it's not using that. I can do the same thing with this as well. Just ignore that because we're not using it for now. Let's go back to the command line. Boom. And let's hope that everything else is in order and it runs. So we can also run this from the REPL as well, and we can start and stop the. Oh, am I calling handler somewhere? Where is that? Line 61. Oh, yes. Oops, I did forget something. I apologize. I had this in the back of my mind. I hadn't changed it. So we've got this def routes that we've defined. And previously we were just passing everything to a function called handler, and that was essentially our one single route. But we've changed the function that we want to deal with all the requests, so we now need to change this in when we're actually running the server itself. Or maybe that was the issue. Okay. Web app. There we go. So we changed it to the name of our def routes, and so def routes is effectively the overall control for our application when we run it. And now if we switch back to our, boom. Was that the same error? No, it was a different error. Okay. So it's fingers crossed, third time lucky. Oh, there we go. So we've started HTTP kit on port 8000. So if I go back to the browser, just to show it is definitely working. There we go. Hello Clojure, Server World. Woohoo! So if we go to hello response, we go to a different address in this server, then we get a different response. We get a different page that's served up there, and we can go in and add. We can go in and add whatever routes that we actually want in our application. We can add as many routes as we want to, and again, there are all the routes are simple one-liners that we can add, and we can put all the complexity of how we deal with a particular request into a separate function. And again, if there's commonality, we can pull out functions, helper functions as well to do that. We can use the ring and compojure helper functions to do things as well. Okay, any questions so far? No questions. Cool, everybody's still here. Cool. Okay, where did we get to in the blog? There we go. Nope. Oh, wrong one. That's my crib notes. There we go. There we go. Oh. There we go. So we can also generate JSON from Clojure. So typically when you're serving up APIs, then it's kind of the language, the common approach is to use JSON, partly because JavaScript has become so prevalent on the client side of things. So if you've got a web user interface, it's there's a good chance it's being written in JavaScript or a language that works with JavaScript. So it could be TypeScript or ClojureScript, or maybe even CoffeeScript, if people remember that far back. And so to be able to pass this data around, then we want a standard structure, and a very simple standard structure is called JSON, which stands for JavaScript Object Notation. And essentially it looks a little bit like a Clojure map, except they put the colons in a different place. And so it's a very simple and possibly cut down version of a Clojure map, but it's essentially a very simple way for you to pass around a piece of information, a piece of data to any other websites, and there's a lot of confidence that whoever's built that website in whatever language can consume that JSON data very easily. And what we're doing is we're going to take JSON data, and rather than work with JSON inside Clojure, which we could do, it's much nicer to actually just convert that into a proper Clojure data structure. And because JSON is more or less essentially a map, we just convert that into a Clojure map. And there could be sections in the JSON file, so we can also use vectors as well to build our data structure within inside our Clojure map. And then once it's in a Clojure data structure, then it's very easy to transform and manipulate and work with all our normal Clojure code. So how do we generate JSON from Clojure? Well, I found this it's always nice to use the kind of standard libraries that come with Clojure. So this is Clojure data.json library, and it's part of the org Clojure group of libraries, and it's just a fairly straightforward library that allows us to convert Clojure data structures between Clojure data structures and the Java object notation. So we can just add this into our dependencies. So go back to my editor, go to the deps.edn file, and so we're just going to add this after compojure. Make sure we get it in the right brackets. There we go. It's all lined up nicely. And so this is just including org Clojure and then the data.json namespace version 22.6, 2.7. and oops. And then we just require that into the namespace as well, so we can actually use those functions. And we're just going to give it an alias of JSON. And so one of the nice things about using an alias is that if you swap out a library, then you don't necessarily have to change your code if the library is just another implementation of the same specification. So, oops. So what I mean by that is, there we go. So if we, add, so we add this here. Oh, we don't need that bit, do we? No, we don't need that bit. Is it going to work? There we go. Cool. A bit of structural editing there. There we go. So we're adding this clojure.data.json as a namespace, and we're just going to refer to this as JSON. So all the functions will just start with like JSON write string, for example. Let's pick that up already. And if we wanted to use a different JSON library, then we'll just put the new namespace in here as well. And if it's got the same functions, then there's very little to actually change. If we've got different functions, then obviously we're going to have to do a little bit more refactoring in there as well. But having an alias that basically describes what the purpose of that particular namespace is it can be quite useful. And so we've included it as a dependency and a namespace. So we actually just need to actually use it as well. We need it, so we need a root, and we need a few other things as well. So we can just call JSON. We've got a write string and a read string. So if we want to generate some JSON format from Clojure, we pass in a Clojure data structure. In this case, it's a Clojure map with just a couple of key value pairs in there, and it will generate the equivalent JSON. And we've got read string as well, which will read in some JSON and pull and return the Clojure data structure for us. And there's a couple of other libraries there as well. There's like ring JSON and ring JSON response that also do these kind of things. And there's many other kind of libraries that we could use. There's transit, and I think I've mentioned another one at the bottom. Oops. Yeah, there's oh, did I not put them there? Oh yeah, there's Cheshire, which is a classic one, JSONista and Transit. So there's quite a few different libraries to go and choose from. There's a nice thing about Clojure. You can go in and choose the particular library that suits your needs best. And if you're never quite sure what library to use, then actually there is a new channel in the Clojure in Slack, which I think is called What Library. And you can go in, if you want to do something and you're not sure what library to use, then you can go in and ask on that channel, and they'll offer you their opinions on that. Okay, so we've got the library in here that allows us to be able to write some JSON, and so we'll create an API in here as well. So we're going to define this scores function, and I did this yesterday, so I don't have to you don't have to watch me type this all in. And so what this is doing, we've just got a debugging statement in here just to show it's working. So this will print out on the command line, and we're defining some headers because we want to serve up a specific type of response. So rather than just being a web page, we're specifically going to return JSON. So our client knows the type of something, so it can kind of display it properly. Because if it's JSON, then it's not very, you don't really get a nice view of that JSON if you're just printing that out as text on your web browser. Normally you'll consume this, but via like just an application call, so you won't be looking at the JSON specifically, but sometimes it's useful to actually look at the JSON as well. So regardless, putting the content type in helps understand what to do with the request. And we're pulling in a status of 200, so we're sending back an OK status, again using just that lookup map that we defined. And the more interesting thing is for the body, we're just going to write some JSON. So we've got this JSON library, we're using the right string, and we're taking a Clojure map, a Clojure data structure, and it's got a list of players in here. So this is going to translate, we're just going to translate this into JSON and send that back as the result, as the body of our response map. And we'll need to, we've got the handler, so we just need to add this to our roots. So we'll add a new root in here, and it's pretty much going to be the same as this one. So just copy this. So we need to give it a unique address, and we're going to call the specific function in here, which will be scores. And so we've updated the Webapps thing and the scores. If we were using our editor that was connected to our REPL, we could just change. We could reevaluate these and they would work. But because we added a dependency, we need to restart our server anyway. So if we go back to here, we can just Control C, that should kill our server. Let's just go and check on the browser. Oops, pressing the wrong button. So now that's not our browser. Did I close it? I think I closed it. There we go. Too many files open. There we go. If we go back to our local host, this should be not working anymore because we killed the server. That's good. And so we can restart the server again. Again, just do that. And hopefully if I've typed, oh, I've done something wrong. Oh, end of file. Oh, I've got a bracket in there. Too many. Oops, I think that's when I pasted in that that last require. Copying and pasting is a little bit dangerous in no. Oh yeah, well, that's not happy. So if I go and see where the matching one of that is. Oh, we don't have a matching, what? Oh, have I got one missing from there? Oh, okay. Okay. When I did the structural editing, it kind of did that as well. Let me just add an extra one of those. Let's copy that, paste that. There we go. Hopefully that should be happier. Yeah, there we go. Oops. So with the code fixed, we should be able to run the server again. Fingers crossed. Boom, boom, boom. Come on. Can I code today? What's going on? Oh, doesn't like my JSON. This was working before. Let me switch back to, so I can do this in my editor as well. I've got my editor connected to well, I can run my REPL from here and it will connect my editor to the running environment. So this is the same code I was working on yesterday. We've got the response here, and we've got the clojure data.json as there. So let's see if we can run this from here. It's always the joy of live coding. Sometimes things get messed off. Did I do anything else in here? Nope. Oh, we've got scoreboard. Here am I. Yeah, so I've got scoreboard rather than scores here. And it's basically, yeah, it's just a players, and the player's key has a value of a vector. And then we have multiple players, each with a name and a high score. And did that work? I think that worked. Yeah, so we've got a REPL in here. Okay, so I'm going to evaluate the namespace. I'm going to change it to the namespace. Oops. I think. There we go. Yeah, so we changed the namespace. I'm going to evaluate the whole buffer. So I'm going to evaluate all my source code in here. And switch to here, and now I can call main, so I can start the server, and it's listening on port 8000, sorry. So if we try again, there we go, and we go to the scoreboard on here, then we get our JSON. So it's returning our JSON, and Firefox is kindly presenting that in a nice format. It's taken this piece of information from the headers, that this is a like an application JSON format that it's received as a response. So it's put this nice little front end onto what otherwise would be the raw data. So this is what it would normally. This is what it's been sent back. So this is our JSON that's been sent back, and it's you can see from the headers, it should be. Yeah, so here we go. The content type is JSON, so that's pulled it back from what our request is. It's even pulled out what the server is as well. That's quite interesting. And Firefox has got this nice JSON render as well. So in this tab, it's helped us kind of see, visualize the JSON results as well. So that's quite nice. I assume there's probably something in Chrome as well that does this. But that's quite nice. So we can see how we can send back JSON and build our API that way. And it is just a matter of adding routes and deciding what data we're actually going to send back, and defining like the content type, if it's so whether it's going to be HTML or whether it's going to be JSON or something else, and then just defining all our routes and the as well as the routes, the functions that we're going to use as handlers to handle each particular route request. And that's it. If the one advantage of running this in your editor is that I can go in and change these functions to make them do different things. So especially like if I want to change the handler functions to give us different responses, then I can simply re-evaluate the code when I've changed it, and then it will update that function definition in the live running REPL that my editor is talking to, and so then my browser is automatically updated as well. And so so as I'm adding, I can add more JSON in here as well, and it would basically serve up more information. Would serve up that extra information when I reevaluate scoreboard. Let's just give it a try, see if it's going to do that. So let's just add another name here. Boop. What are we going? Let's go to Fred. Fred's got the same high score. That'll do. So if I reevaluate that, so it's basically the same as typing this in again to the REPL. Then so it's basically pulled that into the REPL. And if we go back to the browser and I refresh that, which will basically do a new call, new request, yay, then I've got more JSON. So I don't actually need to start and stop my server each time when I'm using my editor connected to it. And you can do this in the REPL using the command line REPL and REPL read line as well. You just have to paste that code or write that code into your REPL and it will update, and you can just rerun those requests in your browser and you'll get the new updated information. So anything that is where are we? So anything that is after the call, so all the requests are coming through the server, and the server is handing everything off to this web app. And because we're using this hash quote thing, it's not evaluating web app. It's going to actually, the server has a name to it, as a reference to it, so we can keep on sending code to that server via the web app. And if we evaluate web app or anything that web app is calling, then those definitions will be included in the live running server. So we can have this pretty rapid response without having to start and stop our server every time. Obviously, as our system gets more complicated, then it is worthwhile considering something like a component lifecycle management library. So there's one called component, one called mount, there's one called integrant. Those are the three main ones I think that people are using. And there is an example, if you go to the blog that I've just written, I think down the bottom, I think I did link to, this Sean Caulfield has this user manager project, which is a nice example of using all the things we've done, except the only difference is we're not, it doesn't use HTTP kit, it uses Ring, but it's using component for the lifecycle management as well to start and stop services. So if you've got things like databases and other data sources, and it allows you just to start and stop those in a nice kind of controlled way, and you can also start and stop your web application server as well. Cool. Any questions? Oh, no questions. Excellent. I think that's everything I've covered. I don't think I missed anything off. Yeah, there we go. So one thing I didn't quite get a chance to finish actually. I'll do this later on. So we could define a route, and we could so instead of doing scores, we could pass in a specific name, and we'll be able to pull this name out of the request, and then pass this to either to the scoreboard or by giving that an optional argument, or we could write a new player score function as a handler, and that would take the player's name and return just the score or scores for that particular player. So there's quite a few things there as well. Again, I've got some examples in the Clojure web apps for doing that as well. So I'll add that. I'll add that to the blog afterwards, and I'll leave you to go and experiment in creating your own routes and generating your own APIs. Okay, well, that was a very simple kind of introduction to that as well. But everything that you kind of do, all the things you do with like Cheshire and JSON instance and so on, are kind of built on that. So having that understanding is quite useful. Then it makes it very easy to debug things when they go wrong. I hope you found that useful. And so we'll continue with this next time, and we shall build more of an API, but also start to consume the API as well. So we can build like a client either on the server side or on the just on the command line, or even on the in Clojure script, and then actually do things with our information that we're returning. And we can also try out other people's APIs as well, and do things with so there's lots of public APIs. Usually you do need some kind of an account to be able to access it. That stops people like spamming and doing a denial of service attacks on those APIs. Even though they're public, they do want some kind of control over it, just to make sure that they're going to still be healthy. So we'll look at doing that as well. And yeah, so thank you very much for joining, and see you next time. Thank you. Bye.